Welcome to the Center of Excellence, Schneider Electric Lab. Our lab is Schneider Industrial Automation. We are going to see what is meant by Unity Pro. Unity Pro is nothing but a software to increase the design productivity and performance of your Modicon PLC of the model M340 and M580 applications. The software we use it, Unity Pro S, for our application. What is SFC? SFC is nothing but Sequential Function Chat. It's a graphical programming language for PLCs. It is one among the 5 languages defined by IEC 611313 standard. The SFC standard is defined as preparation of function chart for control systems. It can be used to program the process that can split into steps. The basic SFC has the important elements. First element is the step, which is associated with actions. Second element is transition, which is associated with logic condition. Third element is directed links, which joins both the transition as well as the step. Now we are going to design an application by using the Unity Pro software with the same drilling machine, but it has to perform the operation by means of the cycles. It has to perform the same operation twice by using the timers and counters. That is why we named this as a cyclic mode. Okay, under the specification, when the workpiece of the metal is on the drilling place, the drill is not put in rotation and it goes down to reach the low position, and the motor is switched on for 2 seconds for drilling and reaches the intermediate position. But the operator not satisfied with the whole drill, hence once again he wants to reach the low position drilling for 1 second, and the head reaches the intermediate position. The same process from the intermediate position is repeated once again, that is 2 cycles. After 2 cycles, it goes for the cycle check. If it is completed, it will go to the normal position, that is the head goes up and it is stopped in the high position. If not, the cycle is going to repeat it once again. At the end, the operator removes the piece of the metal. So introduction.
So here we are going to see the drilling machine operation with twice the time the drilling, which can be done in 2 cycles. So for that we are using 2 functional blocks. One is the timer, next one is the counter. So counter we are not using directly. Instead of that we are using the operate block and compare block. So this is our application. So in short, I am going to drill a workpiece 4 times. Okay, first time I am drilling, I am not satisfied, going for the second time. Then I am going for third time, I am not satisfied, once again going for fourth time. So 2 cycles is completed, I am going to end the process. So this is the application. So how we are going to do? We know already, so this is the drilling machine. We have 4 sensors. One is the high position sensor, intermediate position sensor, low position sensor and position sensor. And we have 3 outputs. So one is the cylinder extend, one is the cylinder return and drilling motor on. So this is the inputs and outputs. So when I press the first 3 buttons, that is push button has to be pressed, it should be in the high position and workpiece should be there. If that condition is there, what will happen? Immediately it will come there, come to the low position and it will start to drill by waiting in the low position for 2 seconds. And it sees my drill hole is proper or not. I am not satisfied. So once again it will go to the intermediate position. And once again it comes, we have to, I am not satisfied. So I am making it to come to the low position. So once again it will come for the low position second time and it drills for 1 more second. So totally 3 seconds for 1 drill. So this is done. Now I am doing the comparison operation. So I told already we are going to do 2 cycles. Okay, in 1 cycle there are 2 times drilling is done. So now once again it will go for here only, that is in the low position only, it will check for the condition, that is 2 cycles is completed or not. If it is not completed, once again go to the intermediate position. If it is completed, it will go to the first position, that is initial step, so the process will end. But now, as of now, only 2 times it is done. We have to do it for 4 times. So only half the condition is satisfied. Now it will check for the cycle. If cycle is equal to 1 or cycle is equal to 2. The cycle is actually 1. So what will happen? Once again, it will go for the intermediate position. Okay, and check for the cycle. So cycle is equal to cycle plus 1. Here actually cycle is equal to 1. Here is equal to cycle is equal to 1 plus 1. So it is the second cycle. Okay, so in the second cycle, once again it will come for the low position and it will starts to drill for the second time. Okay, second time for 2 seconds. I am not satisfied. Once again it will go for the intermediate position and it will I am checking for the cycles also. Then once again it is coming down. Okay, and once again it is coming down here. I am waiting for the time delay for once again here. So this is the 4th time I am getting the drilling. In this condition, here only the check will happen, cycle check. Here also the cycle check will happen. If yes, it will end the process. So I have completed the 2 times. So once again it will go to the high position with the drill motors on. Okay, otherwise it will go to the one more like this step will come. Okay, so once again I will repeat in short. So we are having the drilling machine. Initially it is in the high position. Then when we press the 3 buttons, what will happen? Immediately it will come to the low position and it will be start to drill for 2 seconds. I am not satisfied with the drilling. Once again it will go for the intermediate position and it will come back to the low position and it does one more drilling. Okay, so twice the drilling and this is known as 1 cycle. Okay, now I am checking for the cycle. The cycle is not satisfied. So I want to go for an additional cycle. So once again I am coming down. I am coming back to the intermediate position. Then once again I am doing the 2 minutes drill here. Once again I am doing the 2 minutes drill. Sorry, 2 seconds drill. I am not satisfied. So once again I am going up and coming back to the low position. So totally 4 times 2 cycles the drilling is happening. So here the condition check will happen. The condition check is if cycle is equal to 2. If not, it go to this step. If cycle is equal to 2, it will go to the initial step. Like if else statement. If condition is satisfied, it will go to the final step. Otherwise, it will go to the loop. So here, the number of loops we are given is 2. That is known as the cycle. So we will see the programming, how to program this by using these blocks in the system.
Hardware configuration. The hardware configuration is similar to the previous experiments. We have the list of inputs, that is push buttons, high position sensor, low position sensor, intermediate position sensor and piece position sensor. And the outputs we have drill motor on, cylinder extend and cylinder return. So the beauty of the PLC is all the inputs and outputs will be remaining the same. There is no change in the hardware. So whatever may be the application, just we are going to change the data logic diagram or program. So here same is applied. Here we are just going to change the SFCs. The hardware is fixed. So let us see the programming procedure of the Unity Pro.
The next application is SFC application for drilling machine with twice the drilling and 2 cycles it has to be done. For that I'm taking the same outputs, that is drill on, cylinder extend, cylinder return. I'm giving update grid, it is updated. And next I'm taking the inputs similar to the previous experiment, that is the push button, high position, low position, position sensor and intermediate position sensor. Okay, and as usual I am doing the configuration, that is the Ethernet configuration. Here it is correct. So now I will be going for the PLC bus. The PLC bus I am going to check the input and output modules is fine. Now I am going for sections, checking for new section. I am going to draw a SFC. So I am giving the SFC with the name application 4. So I am given the application 4. I think now you can see the screen. In this I am going to take 6 steps first. Then 2 more steps I'm going to add. So I'm going to update with 6 steps. I'm giving OK, dragging and dropping. So I'm changing the name. This, I think this and all is similar to the previous one. S0 I'm going to give. I initialize as initial step, and next is S1. Later it is S2. Give OK. Third one is S3. Next is S4. Giving OK. Next is S5. So first I'll do with this 5 steps. Later I will add one more step. So I'm given S5. Okay. So now initially I'm going to transition from S0 to S1. So I'm going to click here. So transition section. So what is the transition section is? S0. It should be in caps. S0 underscore S1. I'm giving OK. It should be in ladder. So it has been created. So I'm opening this. I'm bringing to S0 to S1 here. So I have to give the 3 inputs. So 1, 2, 3 inputs I am giving. I'm naming it as, first one is push button. So I will give the push buttons first, PB. Then OK. Then it should be in the high position. I'm checking for the high position and giving it OK. Then I'm going for position sensor, it is there. So this is fine now. Now in the first step, so I want the action plan for the first step. For the first step, I'm going to give drill on and cylinder should extend. For that, I'm going for section, new section. I'm giving it as actions. I've given as actions. It has to be in the form of ladder logic. So I'll redo it. So sections, new section. So it should be in LD. It is actions. So you can see the ladder logic diagram. First, I want the drill on operation. For that, I'm dropping 1. And next, I want the cylinder extend operation. So the drill on operation is happening in the step 1, and the cylinder extend is also happening in step 1. So I can rename the output. So it is actually drill on, and this is cylinder extend. Okay, here it is happening in the step 1.x. So you go to inside structures, s1.x, and I'm giving OK. Also OK. Here inside structures, here is also it is s1.x. We're giving OK. Once again. Okay. Sorry. So it is actually cylinder extend. So it is cylinder extend. So this is changed now. Okay. So in the SFC I'm coming back. So it's the initial step. So I'm doing the transition. The transition I'm giving, the drill motor should on, and it should be reaching the low position with the extension. So here I'm giving the variable as low position. To the low position. After it reaching the low position, so I have to give the actions for this. In this action also, what I will do, I will make the drill motor on. Okay. So in S2.x, what will be happening? The drill motor will be on, because directly it is coming to the lower position and it is making the drill. So here I will make it as S2.x. I'll double click on it. Inside structures, it is S2.x. Okay. Now waiting in that low position for drilling for 2 seconds, so that I will open one more new section. It is also in LD. I will add the timer. So this is the timer. I am adding it here, and I am dragging and dropping a timer. So it is T on. So timer on. I am dragging and dropping it here. Okay. The name of the timer is T on 2. Okay. So enable bit will be joined as usual, and input should be s2.x. I'll double click on it and go to s2.x, and I'll make it okay. So now I have operated the timer. Here the time delay I'm going to give is 2 seconds. So the drill should happen for 2 seconds. Okay. After the 2 seconds is reached, drilling is done. What will happen? The cylinder should return back, so that the action plans, I'm going to give the command as cylinder return. So s3.x as cylinder return. Okay. So I'll double click on it. So in this, the cylinder will return back. Cylinder is returned back in the S3 step. Say structures and S3.x. Again, okay. Now the cylinder is started to return. Okay, up to which position? Before that, the S2 step, after the timer is energized, so we should bring the timer output, that is Q bit I have to bring. For that I'll go for functional block, name by default, I'm using T2. Okay, it's output I'm taking, this Q bit, bring here. Okay, after this, so once again I repeat, it is the initial position S1, S0 to S1 it will reach by pressing all the 3 buttons. S1, drill motor will on, and the cylinder will start to extend. To which position it will extend? Up to low position. S2 I'm performing the drilling operation for 2 seconds. After the 2 seconds is reached, once again I'm giving the action plan. Cylinder should return back. To which position? I'm going to give it as intermediate position. So here variables. So remove this inside structure. Intermediate position. Okay. So I'm seeing that the drilling operation is satisfied or not. The drilling is not satisfied. Okay. So that once again I'll ask the drill motor to come down. So second time I'm doing the action plan. So in step 4, the action plan will be cylinder extend and drill on. So here I will come for the action. So here one more point to be noted. In step 3 also, the cylinder will be the drill on will be in the on position. S3 step also, it is the on position. Similarly, S4 step also, it is in the on position. So it is drilling on, and in S4 one more cylinder is extending. Cylinder will be extending up to the low position. So here I am giving S4.x. Okay, now I'm coming to the chart. Here it will be cylinder will be start to extend up to the low position. So here I will name the variable as low position. It has low position. Okay. So now I'm coming to the S5. The S5 I want to add one more timer or one more drilling operation. So here in S5 also the drilling will be on as well as the timer will be on. So I'll come once again come for timer and I will make it as S5. In S5 step is also the drilling motor is on. So I'll make it as inside structures S5.x. Okay. And I'll come to timer. One more timer I'll add. So I'll click here. I'll get the timer T on. Okay. timer number is T3. Here I'm going to connect it with the input. Here the input will be given in the step S5. Okay, so I will take the structures, C structures, S5.x, and I will make a S5.x. Here the drilling machine is going to wait for some time. So what is the time? The time will be 1 second, 1s. I'll update that. Okay, I'll update. So now the drilling machine is operating this. Now one time it is done. Okay, so now I want to check for the condition. For that condition, I have to draw the alternate branch. Here you can see. So this is the new one. You might not have seen. So this is the alternate branch. So I will put the alternate branch here. Okay. I'll put the alternate branch here with two transition condition. Okay, I told we want to complete the 2 cycle. As of now, only 1 cycle is completed. 1 cycle is not completed. What should happen? It should go to the step 3. So for that, I'll take this and join it here. Right. I will join it here. So what will happen? So once again, it will come down to the S3 step. The S3 step, it will check for the condition. Okay, how the condition will be checked. Okay, so here S3 condition, what is the action plan? The S3 condition, the drill motor will on, and once again cylinder will start to return. It will come to the intermediate position. In the intermediate position only, actually the comparison should happen or counting should happen. How many cycles completed or not. So once again I am going to open a new section. In that I am going to draw a ladder diagram with counter operation. I am naming it as counter LD and I am going to give OK. So the counter is opened. Here I am going to drag and drop the operate block. So I will drag and drop the operate block with the values. So I want to make it as CYC. CYC. Okay. Colon is equal to CYC plus 1. So and I will close it with a semicolon of this. Okay. Now I want to put a pulse here because it is doing the counting operation. So I will put a pulse and I will join it here. So this side also we should join. So this comparison is happening in the S4 step. So I will take the address of S4.x. So our program requirement is this should be done for 2 cycles. So 1 cycle is over. Here it is checking 1 cycle is over or not. Since 1 cycle is not over, it is coming here. So here cycle will be added. 1 plus 1, 2 cycles. And once again it will come and check here. 2 cycles is over or not. Then if it is over, it will go to the high position. If it is not, it will from the, for that only we are taking this counter. Okay. After that, the S4 step, once again it will check the low position. Once again S5 we are given the timer, so it will wait for the time. And once again the timing operation will be done back. Okay. Now I want to check for this conditions. Okay. Here for that condition we have to check for the transition. Okay, if the cycles is not complete, okay, I told already it should go to the this step. So from S5 step to S3 transition I am doing. So the transition will be S5 to S3. So that will be the output. I will double click here, type S5 underscore S3. Okay. So it is here you can see one more transition is open. So double click on it. So this is the output. So if this is the condition, what is the comparison block? So I have to compare. In this step I told already I am comparing. That is 1 cycle is completed or 2 cycle is completed standard, I want to check that. Okay, so that I'm making this, and I'm going to see that here one more compare block I'm inserting in between, and I'm giving the condition as cyc, cycle cyc is less than 2. Okay, so here the output is from the timer. So which timer? So it is from the timer 3. So now I can drag and drop the input here and double click on it. Go to the timer, functional blocks, named by default. This is the second timer, so I am taking as timer 3. Delayed output I am taking here. So if the cycle is less than 2, what will happen? The the sequential functional chart, we go to step 3 once again. If it is completed, it will take the alternative branch. Okay. Now in the chart I can explain. So here S5, here twice the drilling is done and checking for 2 cycles. If the cycle is less than 2, what will happen? It will go here, do one time drill, then once again I will come back to the low position and once again do the drill, then it will come for the cycle. So if the cycle here also I'm going to do one more thing. 2 cycles completed means we'll go for the next step. For that same procedure I have to follow. It is S5 to S6. So the condition is S5 underscore S6. It's also LD. So here the condition will be, here you can see, this is the output. So here if the cycle is completed, okay, so that I am putting one more compare block and I am giving the equation as cyclist 2. The cyclist 2, we can release him, not to follow the loop. Okay, so the cyclist 2, the input will be coming from the same timer. So it is timer 3.0. Timer 3.0 output. Here I will be taking the Q delayed bit. Will give okay. Now here you can see the chart. If the cycle is less than 1, it will go for the next cycle. The cycle is equal to 2, it will go for the next step. Okay, here I am going to insert 2 more steps. Okay, go here, I'll give 2 more and I'm going to join with this. So I drag and drop 2 more blocks here. So I can name it as S6. Cycle is not equal to or less than 2, it will complete 2 twice the drilling. Here the loop will be rotating for twice. If it is completed, here we have to give some condition, no? For S6, so what is the condition? So here we can give the action plan as cylinder return back. If it is twice, if it is done, so there is no need of doing the drill once again. So we can stop the drill. So that here we'll name it as S6 or X. You can give the inside structure as S6 dot X. Okay, but here we don't know the operate cycle is how much. Previously the operate cycle was 1 plus 1. Here the operate cycle should be 0. So once again I will come to this. I will insert one more operate block to make the cycle as 0. Otherwise, you will get error. So I will join this and I will make the cycle as 0 and I will give the address as S6.x because in that step only it is happening. So it checks this and you want to give the condition as cyc, okay, colon equal to 0. which part it has to return back up to the high position. So I will come to the variable and I will check for the high position. So cylinder, the head reach the high position. Here no operation will be there. Add the different type of workpiece and give the new workpiece. For that we have to invert the condition. We can give OK and we can join the loop to the first condition. So I have made the first condition. So now it is ready for 2 times drilling cycles, that is 4 times for the next workpiece. So remember, you have to draw this all the steps with first transition condition, then second transition condition for less than 2 cycles, and if the cycle is satisfied, the third transition condition, and also here count how many times it is counting. That is also you have to draw, and 2 timers you have to do. One is at the S2 step and next one is the S5 step. So if this thing is done, you can get now. So I will check any errors are there for this. So as of my knowledge, no errors are there. I'll go there and I will start to check it and I will run the program. Okay, for that I'm going to build it. Okay, fine, error is not there. Set address, the same address 137, fine. Okay, I'm going to give PLC connect. So connect is connected. Transfer the project to PLC. Now the program is ready for run. So once again I repeat, in this application we are doing the drill 2 times first, then I am checking for first cycle. Once again I am going for the next cycle 2 times drill. If that is satisfied, I am ending the process. In total I am doing the 4 times drill. How it will be executed? Let me see in the hardware circuit.
There is no major change in the connections because as already we have discussed, the same connection can be utilized for all, only change in the ladder logic diagram or SFC. So same connections are maintained. Now we changed the program for 2 cycles. Let us view the output.
We discussed earlier. So here we are going to see the two time drilling and 2 cycle experiment. So now we are going to see the procedure how it is working. So first I have pressed the push button and it is in the high position, then workpiece is there. So the drill motor is on and it is started to extend. Up to the low position it will extend. It reaches the low position and it will drill for some time and it will start to return back. It will start to return back up to the intermediate position. So here you can see this is the intermediate push button. I'll press it. So the intermediate position it reaches and once again it check for the cycle. The cycle is now as of now only 1 cycle is completed. So it will check for the cycle. Now the next is once again it will go for the low position switch after this because the cycle is not completed, right? So it will come to the low position. So because cylinder is in the intermediate position to the low position, so I will check the low position. Now 1 minute drilling is done. So twice the drilling is done. Now once again it will go to the up and it will reach the intermediate position. In intermediate position, the cylinder will start to extend. So it will extend up to the low position. Meantime, it check for the cycle also. Now the cycle is 1 plus 1, 2 is yet to complete. So it comes to the low position and it wait for some time for drilling, and the cycle is completed for twice. So cylinder will starts to return back and it will reaches the high position and the entire process will stop. So here we can see in the SFC diagram, it comes to the first position, that is the initial state. So this process can be prolonged as long as we can try it. But as per our application, we are drilling the workpiece first time. If it is not satisfied, we are going for the second time, and we are continuing the same process twice. So here we are using a timer as well as the counter. For drilling twice, we are using the timer, and for counting the cycles, totally 4 times the drilling is happening in it, to ensure that we are making 2 timers and 1 operate block and 1 compare block. The 5th application can be modified by replacing this operate block and compare block, and by using a single counter we can modify it, but same operation. There we have to set the counter and reset the counter. So we can give the counter set value as 2, and we should give the counter set value counter set value is 2 and reset value is equal to 0, so that we can achieve the same application. Yeah, thank you.
Thanks for watching.